Mark.
30 seconds to launch. At T0, the two main engines will ignite after about 1.5 seconds to conduct health checks. Antares will lift off. Point of reference, the space station is 262 miles up north of the Michigan Peninsula at the time of launch.
4, 3.
Go Antares.
1.
Engine start. Liftoff of the Antares A-ONE test mission from the Mars Pad 0A at the Wallops Flight Facility. EVC nominal, attitude nominal. Power is nominal. Engines at 108% and nominal. Attitude nominal. Core pressures are nominal. Altitude 2,000 feet. Plus 30 seconds, EVC nominal. Engines at 104 and nominal. Attitude nominal. Avionics power is nominal. Attitude nominal. Core pressure is nominal. EVC is nominal. Altitude 10,000 feet. Engines are nominal. T plus 60 seconds. Power is nominal. EVC is nominal. Core pressure is nominal. Altitude 20,000 feet. Velocity 900 feet per second. EVC is nominal. VNO3 on. Core pressure is nominal. Vehicle passing through max Q. Attitude nominal. Plus 90 seconds. Power is nominal. Engines remain nominal. Altitude 50,000 feet. Velocity 1,600 feet per second. EVC is nominal. Attitude nominal. VNG3 on. Core pressures remain nominal.
Beautiful view.
Engines at 100% and nominal. Avionics power is nominal. T plus 2 minutes. EVC is nominal. Attitude is nominal. Core pressure is nominal. Altitude 100,000 feet. Engines remain nominal. Attitude nominal. Power is nominal. Approaching MECO. Core pressure is nominal.
Kyle, we're coming up on main engine cutoff.
Attitude nominal.
That should come about 3 minutes, 50 seconds or so into flight.
EVCs are nominal. Altitude 100.
Stage 1, throttle down.
2 minutes to MECO. Core pressure is nominal. Attitude nominal. Power is nominal. EVCs are nominal. Engines are nominal. VNO 4, 5, and 6 are on. Core pressures remain nominal. Attitude nominal. EVC nominal.
Standing by for engine throttle down.
Altitude 250,000 feet. Core pressure is nominal. Engines remain at 100% and nominal. T plus 3 minutes, 30 seconds. Throttle down has begun.
Traveling about 7,200 miles per hour now.
EVC is skewing out in preparation for the MECO event.
Standing by for stage 1 MECO and separation.
MECO. ESS is disabled. We have stage 1 separation. Lower ACS is enabled. Closed loop guidance is enabled.
4 minutes, 20 seconds into the flight. All, as you hear, going very smoothly.
327 second sequencer time.
Kyle, the next mark event will be fairing separation.
Antares is now in a coast phase until proper conditions for fairing separation and stage 2 ignition are achieved. Power is nominal. Attitude nominal. Power nominal.
That's a view inside the fairing, right? Yeah.
That's correct. View looking forward now.
Power is nominal. Awaiting fairing separation in preparation for interstage separation and then stage 2 ignition. All systems remain nominal at this time. Avionics power is nominal. Fairing separation. Interstage separation. Attitude nominal.
Standing by for stage 2 ignition.
Stage 2 ignition. Attitude nominal.
Stage 2 ignition comes at an altitude of 117 miles.
Power is nominal.
Traveling 9,400 miles per hour.
PVC nominal. Attitude remains nominal.
So Kyle, now we see an animated view of the vehicle, the second stage.
Avionics power nominal.
As reported, burning nominally.
Attitude nominal.
And
looks like stage 2 burns for about 2.5 minutes.
Power nominal.
That's correct.
PVC nominal. Attitude nominal. Power is nominal. PVC remains nominal. Attitude nominal.
Well, this is an animated sequence. We are receiving direct telemetry from the vehicle
Power is nominal.
that corresponds to this animation.
Attitude nominal and PVC steering is nominal. Avionics power is nominal. Attitude nominal. Still good, strong telemetry here in the RCC. Motor pressures look nominal.
We have about 1 minute remaining before stage 2 tail off begins, and the stage 2 coast phase begins just a little bit after 8 minutes into the flight. We're currently at 7 minutes, 10 seconds.
Attitude is nominal.
Kyle, there you see a great shot of the second stage powered flight.
Power is nominal. Attitude nominal. Power is nominal. PVC nominal. Attitude nominal.
And we're standing by for stage 2 tail off.
20 seconds till burnout. Attitude is nominal. Motor pressures look good. PVC performance is nominal.
Speed is now 16,600 miles per hour.
Attitude nominal. T plus 8 minutes. Power is nominal. Attitude nominal. PVC is nominal. H2 tail off. H2 burnout. FTS disabled. Antares performance is nominal. First P-pod separation. Antares is in orbit. Attitude nominal. Antares will coast for roughly 100 seconds to allow residual thrust tail-off prior to the test mission payload separation. Power is nominal. Attitude remains nominal.
So Kyle, now we're in an unpowered coast until we come up to the
Second P-pod separation.
mass simulator separation. As you hear
Attitude nominal.
being called, we're also deploying the secondary payloads that we discussed earlier.
9 minutes.
Everything's going very smoothly. That Cygnus, or the mass simulator separation, comes about 10 minutes, just about 1 minute from now.
Attitude remains nominal. Power remains nominal. All systems for Antares remain nominal as we await payload separation. T plus 9 minutes, 30 seconds. 30 seconds to payload separation.
That mass simulator separation is going to occur at an altitude of 158 statute miles, about 255 kilometers.
Attitude nominal.
About 15 seconds from separation.
Power is nominal. Attitude nominal. T plus 10 minutes. Payload separation.
Kyle, as you can see on the animation, the payload has separated successfully.
It's a beautiful, beautiful mission, and it's got just a few more minutes to go.
And attitude is nominal. Antares has delivered the A-1 test mission payload into orbit.
You see, congratulations all around in the Range Operations Center there. And as you mentioned, the mission itself has about 8 more missions as we execute a collision avoidance maneuver on the upper stage with the attitude control system.
And you'll see the, you won't see it necessarily on the animation, but the collision avoidance, it actually orients for that. It's a contamination collision avoidance maneuver that comes about 15 minutes into the flight. We're at 11 minutes right now.
Payloads. And that's all we have here from the control center in the RCC at Wallops Flight Facility.
And you were listening to Mike Dorsch after liftoff, the Antares chief engineer. He was making all those calls that you heard going all the way uphill. A beautiful, beautiful day for Orbital Sciences. Obviously, John, congratulations to the entire team. That was just a beautiful, beautiful ride to orbit for the mass simulator.
Thank you very much.
The mission lasts officially about 18 minutes and 43 seconds. That'll basically put orbital insertion at 155 by 186 statute miles at an inclination of 51.64 degrees. But all indications are, as you heard with all those calls going uphill, it was just it looked like everything just went perfectly all the way uphill after launch. Launch occurred right on time at 5 p.m. Eastern with engine ignition and liftoff 2 seconds later at 5 p.m. and 2 seconds.
Yes, Kyle, everything looks great. Looks like it was a nominal launch, right on the money. Maybe while we have a couple of moments here, I can take a minute to congratulate not only the Antares launch team, but of course our NASA partner, NASA Wallops Range, the Mid-Atlantic Regional Spaceport, who is instrumental in constructing the launch site and the launch pad that we launched from today, and our key main suppliers, Aerojet, who processes the AJ-26 main engines for us, Moog, who makes the thrust vector control systems for both the main engines and the second stage, the state agencies of Yuzhnoye and Yuzhmash, who did the design, test, and manufacture of the core structures and the propellant management devices, Dnipropetrovsk, who built our core structure ground support equipment, PFI, the thrust frame manufacturer, FFP, the feedline manufacturer, SSP, the pogo suppression device manufacturer, ATK, who supplied the second stage solid motor that you saw burning there, the Castor 30 solid motor, and a few others, Arday, Applied Aerospace Structures Corporation, who built our composites, Ensign Bickford, who provides the separation systems, the linear separation systems, and RUAG, who supplied the payload separation system, Martinez and Turek, who built the majority of the ground support equipment that you saw in action today, AFS, that built the hydraulics that erected the TEL, and Diamond Heavy Haul, that helped transport our booster to the launch site.
It's obviously a huge team to put together a successful launch, obviously, and you saw the launch pad. You know, that was from construction to today was more than 3 years, I believe, just to get to that point, and then the development of this brand new rocket, which obviously looks like it performed flawlessly throughout the day. What, about 6 years, I think, so total. So, of course, that launch pad. You hope to use that again pretty soon, and with the next launch, which will be the demo flight of the Cygnus spacecraft. So,
yeah, that's correct, Kyle. We'll analyze the data from today's launch, and presuming everything is nominal, we're gearing up for the next Antares launch, which will be the COTS demo mission, which will actually carry our Cygnus cargo resupply vehicle and cargo to the International Space Station. Both the launch vehicle and the Cygnus cargo transfer vehicle are currently at the Wallops launch site. The Cygnus vehicle actually has cargo loaded and is being currently fueled for launch operations.
and I think we talked about it this past Wednesday about all in the integration facility. You've got quite a number of vehicles that are in processing, including that, obviously, the Cygnus that will be carried into orbit on the next Antares rocket as well.
Yeah, that's correct. We have a number of boosters that are there at the launch site. One less today.
Which is a good thing.
That's right. And we hope to execute the COTS mission in late June, early July. The window of availability at the space station, we believe, extends through mid-July. As you're well aware, space station is a very busy place, and we are looking forward to our opportunity to successfully deliver cargo to the space station.
Well, I know there's a great number of people that obviously are to be congratulated for the activities today. The mission officially has about 2 minutes remaining. If you look at the clock, it's counting from liftoff now, approaching 17 minutes since the launch of Antares on the A-ONE mission. The team here in Mission Control in Houston obviously followed along with today's flight activities. As mentioned earlier, Courtney McMillan, who is now on console here watching over the station systems, was greatly anticipating today's launch, as she was the lead flight director here in Houston for the COTS demo mission, the Commercial Orbital Transportation Services demo flight with that Cygnus that you just mentioned, John, that is going to carry something like 800 pounds or so of cargo. If that goes well, or when that goes well, it will deliver that cargo to the station and set the stage for the formal flight, which is the COTS orbital mission, known as the Commercial Resupply 1 mission. Brian Smith will be the mission operations flight director lead here in Houston for that flight, which could come by the schedule. We'll wait and see how the schedule plays out in terms of processing and all of that activity. Just under a minute now for the formal completion of the mission, but by all counts, everything went extremely smoothly today with the launch, as far as certainly I could tell, John.
It sure looked good from this perspective. And as you mentioned, we're looking forward to the subsequent CRS mission launches. As you alluded to, the initial COTS mission has about 800 kilograms of payload on board. Subsequent missions will carry up to 2,600 kilograms of cargo to the space station.
Okay.
Okay.
And replay still, you think, at the bottom of the hour?
They're ready now, so it's no hard.
So maybe while we see a little celebration in the Range Control Center, we can take a look at the COTS and CRS missions. As we mentioned, the subsequent missions will carry our Cygnus cargo resupply vehicle. Cygnus is really two main elements: a pressurized cargo module that you see on the front end that is manufactured for us by Thales Alenia Space in Italy, very similar to some of the pressurized elements that are already on Space Station, and a service module built by Orbital that's very similar to the propulsion modules on our successful line of commercial and government satellites. The vehicle will propel itself up near the space station, get in relative proximity to the space station, and then it will be grabbed by the robotic arm of the space station in a manner very similar to other cargo transfer vehicles, and attached to the nadir port of the space station, where it docks and facilitates subsequent cargo transfer. As I mentioned, the initial COTS mission will carry about 800 kilograms of payload. Subsequent missions will carry as much as 2,600 kilograms of payload to space station. There you see what it looks like to unload cargo from a cargo transfer vehicle. Our vehicle is very similar to other cargo transfer vehicles that are currently in operation. When the cargo has been transferred and waste supplies are loaded into the Cygnus, the Cygnus is then unberthed from the space station and released to re-enter and dispose of waste and other expendables from the space station.
It's interesting that certainly it's the most important part of the mission is delivering the cargo to the vehicle, but another important part of the mission is taking trash and unneeded items away from the vehicle, because the space station does not have a unlimited amount of storage space. So that's great, and we're looking forward to that flight. Obviously, as soon as those dates become firm, we'll obviously be setting the stage for that next launch off that same launch pad with that same type of launch vehicle. It's a beautiful, beautiful day for the Orbital and NASA, the whole team that supported this launch, as you mentioned, John. The launch occurred on time today at 4 p.m. Central, 5 Eastern. The 18-minute, 43-second mission is essentially over, but the mass simulator actually will stay in orbit for probably about 2 weeks or so before it would re-enter harmless and burn up harmlessly in the atmosphere.